Let's do algebra. Today, let's solve equations. We'll do 1- and 2-step equations using fractions. Let's go ahead and get started. If we have 1/2 of a number equals 8, if you think 1/2 of what equals 8, don't say 4. 1/2 of, if you got half of a bunch of dollars and that was $8, you must have gotten half of $16. Now let's do it where you have to show your steps. To undo multiplying by 1/2, you multiply by 2. And we do the same thing to both sides of the equal sign. This 2 in the numerator cancels that 2 in the denominator. We get 1x equals 16. Let's do another one. Let's stay with 1/2 because our brains like that number. If you have 1/2 x equals 12, 1/2 of what equals 12? And don't say 6. 1/2 of what? It must have been bigger than 12 because we cut it in half and we got 12. So it must have been 24. If we show our work, how do you undo multiplying by 1/2? You multiply by 2 over 1. And we show the multiplying so that it hits about halfway by this fraction bar. This one's in the numerator and it cancels that one in the denominator. We get x equals 12 times 2, which is 24. Now let's do 1/3. What if we had 1/3 of a number equals 5? 1/3 of what equals 5? Must have been 1/3 of 15. If we do the opposite operation, how do you undo multiplying by 1/3? Multiply by 3. And then you multiply by 3 on this side. This in the denominator cancels that in the numerator. You get x equals 15. There you go. That's the answer, and that's how you'd show your work. Let's do a 2-step equation using fractions. What if you had x divided by 3 plus 4 equals 11? No problem. What plus 4 would make 11? What plus 4 would make $11? Must have been 7. This must have been 7. X divided by 3 gave us 7. What divided by 3 gives you 7? X must have been 21. Now let's go back and show your work that your brain was automatically doing. How do you undo adding 4? Subtract 4. These go away, we get x over 3 equals 7. How do we undo dividing by 3? Multiply by 3. 7 times 3 is 21. This 3 cancels that one. We get x equals 21. Let's do another one. What if we had 2/3 of a number equals 16. I like to think of doing it as candy bars. Okay, here's our candy bar. We break it into this many parts, and 2 of the parts make 16. 2 of the parts made 16. How big was each part? Every part has to be equal. So what 2 equal numbers make 16? Must have been 8, which also tells you that the other one was 8. The question is, how big is that entire amount? This entire amount, it's 8 plus the 8 plus the 8, so it must have been 24. If you're going to show your steps, now you have to undo multiplying by 2/3. That means you have to copy dot flip is what they call it. You take this fraction and you flip it and you multiply it by both sides. So we're going to multiply by 3 over 2, multiply by 3 over 2. This 3 cancels that one, this 2 cancels that one, we get x. We can make this one have a denominator of 1. 2 goes in here once, 2 goes in there 8 times. 8 times 3 is 24. Let's do another one. What if you had 2/5? What if you had 2/5 of a number equals 8? That means you had 5 parts You don't have to be a real good drawer. They don't have to be perfect. But 2 of the parts makes 8. So 2 of these parts make 8. How big was each part? These 2 got broken, added back together would make 8. 8 gets broken up into these 2. They must have been 4, which means all 5 parts were 4. So then how much is all of the parts? 20. And if you're going to show your work, you have to copy, dot, flip. You take this, you flip it, and you multiply it by the other side. This 5 cancels that one. This 2 cancels that one. You get x equals, we can give this a denominator. 2 goes into the 8. 2 goes in here once and into there 4 times. 4 times 5 is 20. Okay, let's do a 2-step equation. What if you had 3/4 of a number plus 3 equals 15? What plus 3 would make 15? What plus 3 must have been 12. This must have been 12. So then we use a picture, do that candy bar, break it up into 4 parts. 3 of the parts make 12. So you break off, you say, okay, 3 of the parts make 12. What numbers are these? They have to be equal. So 12 divided by 3, they must have been 4. The question is, 3/4 of what? What was this entire amount? 4 times 4, which is 16. Now, if we go back and show our steps, we do opposite operation, -3, -3. We get 3/4 x equals 15 minus 3, which is 12. Then we flip this fraction, that's called multiplying by the reciprocal. 4 goes on top, the 3 goes on the bottom, 4 on top, 3 goes on the bottom. This 4 cancels this 4, this 3 cancels this 3. We get x equals, give this a denominator. 3 goes in here once, 3 goes in here 4 times. 4 times 4 is 16. Okay, let's do one with subtraction. And then we'll do another kind. What if you had 3/5 of a number minus 3 equals 12? What minus 3 would leave you with 12? Must have been 15. This must have been 15, because 15 minus 3 is how you get 12. 3/5 x must have been 15. Okay, then when time to draw our candy bar, there's 5 parts. You don't have to draw pretty. Okay, there's 5 parts. We want 3 of them to make 15. 3 of them make 15. Each part was how big? They had to be 3 equal numbers, must have been 5, which means all of those parts were 5. The question is, how much was the big number itself? 5 times 5, which is 25. So the x must have been 25. Going back and showing your work, how do you undo subtracting 3? Add 3. Goes off of this side, we get 3x equals 15. Then we multiply by the reciprocal, which is the fraction flipped. This 5 cancels that one. This one cancels this one. We get 1x equals 15 times 5/3. Give this a denominator. It's easier on our brain. 3 goes in here once. 3 goes in there 5 times. 5 times this numerator is 25. Okay, let's do another kind. What if the fraction is on the outside and we have to do distributive property, it looks like. What if you have 1/2 of a number equals 4? 1/2 of what would be 4? 1/2 of 8. So this has to be 8. the x plus 3 must have been 8. Now we're down to a one-step equation. What plus 3 makes 8? Must have been 5. So first thing we did was say 1/2 of what would make 4? Must have been 1/2 of 8. This must have been 8. Then it's a one-step equation. If we show our steps, we multiply by the reciprocal, multiply by the reciprocal. These cancel, we get the x plus 3, no longer need to be in parentheses. 4 times 2, which is 8. How do you undo the opposite of adding 3? Subtract 3. And you get x equals 5. Let's do another one of those. This time we won't have the numerator be 1. That's okay, we'll get there. What if you have 2/3 of a number? 2/3 of a number equals 10. 2/3 of a number equals 10. That means you had a candy bar. There's 3 parts. 2 parts make 10. So these parts make 10. They have to be 2 equal numbers, so they had to be 5. So the whole thing must have been 15. 2/3 of 15 is how you'd make 10. 2/3 of 15. So this inside of here must have been 15. And it's a one-step equation. What plus 3 makes 15? Must have been 12. Showing our work, we would do multiplying by the reciprocal and multiplying by the reciprocal. This 3 cancels this 3, this 2 cancels this 2. Got a little messy, whoops. Okay, that times 1 becomes 1. 1 times this is just itself, no longer need the parentheses. Now, we have to use a fraction here. 2 goes in here once, 2 goes into 10 5 times. 5 times 3 is 15. We have to do the opposite operation, so minus 3, minus 3. X equals 15 minus 3, which is 12. Okay, let's do one more. This time let's have subtraction going on. What if you had 3/4 of a number equal 12? 3/4 of something equal 12. Let's make our candy bar. Okay, there's 4 parts, and 3 of the parts together make 12. So then each of these parts had to be equal. They each had to be 4, which means every part was 4, which means the whole thing was 4 times 4, which is 16. So 3/4 of what would make 12? 3/4 of 16. So what's inside of here had to be 16. Then it's a one-step equation. What minus 5 would be 16 if you had some money and you spent 5 and now you have 16? What did you used to have? You had 21. Now if we go back and show our steps, multiply by the reciprocal. Okay, if we have this 4 cancels this 4, this 3 cancels this 3, we get 1 times x minus 5, drop those parentheses. Let's give this a denominator. 3 goes in here once, 3 goes in there 4 times. 4 times 4 is 16. What's the opposite of subtracting 5? Add 5. It's what your brain did anyway. So then x equals 21. Okay, we can do one more. What if you had 5/8 of a number equal 15? That's hard on our brain to do, so let's use that candy bar. Okay, we have 5/8. We have to break it into that many parts. Cut it in half, cut each of those in half, then cut each of those in half, and that's 8. So now we need 5 of those. 1, 2, 3, 4, 5. 5/8, and it has to be 15. 5/8 of something was 15. You had to have equal parts. 5 parts, and they had to make 15. They must have each been 3, which means all of the parts were 3, which means 8 parts, and they're each 3. It must have been 24. This must have been 24. So x plus 2 must have been 24. Now we have an easy step. What plus 2 makes 24? X equals 22. Now let's show our work. If we multiply by the reciprocal, we get 8/5. Multiply here, you get 8/5. 8 cancels 8. 5 cancels 5, get 1 times x plus 2, drop those parentheses, equal sign, give this a denominator. 5 goes in here once, 5 goes in there 3 times. 3 times 8 is 24. Then we do the opposite of adding, so we subtract, these go away, we get x equals 22. I hope you enjoyed learning this. You can do your homework now, or you can go practice my math on my website, monumentalmath.com. There's lots of algebra equation solving practice for you, monumentalmath.com. Good luck, and I hope you enjoy the challenge.